Good morning and good afternoon to all our NorthSouth parents. Thanks for joining our first information session for 2021. We have Dr. Anil Sethi, who will be presenting the math information session. So today we are going to have math, and Dr. Anil Sethi is going to provide an introduction to math, what you need to prepare, what is the concept, and all that. He is a professor of medical physics at Loyola University, Chicago. He has served North-South in many capacities, actually for the past 15 years. So this is from a slide from last year. But he continues to serve North-South. He is the member of the North-South Math Core team, the coaching team, workshop team, and all the regionals and nationals. So when we say math core team, he is one of the members who actually prepares all those questions that come on your math contest. He has organized and taught many North-South Math B workshops. He is a regular contributor to our workshops every year. He has coached North-South students in all three levels. Now, coaching is another aspect that we do in North-South. I think we are coming to an end now. But we will have some deep dive workshops. I think Dr. Anil Sethi is doing one of them too later on. Math coach students have gone to state and national competitions. He's very passionate about math coaching and learning. And with no further ado, I'm going to change his screen. So you are the presenter now, Dr. Sethi.
Good morning, good afternoon, good day, wherever you are. And first of all, as Ambu mentioned, my name is Anil Sethi, and I'm delighted to be able to do this presentation and speak with the parents. I want to start out by thanking the North-South Foundation. They've been amazing help to all parents, including myself. Many years ago, when my kids were little, we got involved in North-South Foundation, and gradually I became involved in the some of the activities that Anbu mentioned. So I want to thank the parents who have signed up today, because you have taken that first step on the journey towards excellence for your kids. And years from now, you'll look back and say, that was a smart decision. And another thing is we pretend that we are the coaches and we're teaching our kids, but it's the other way around. The more resources you provide to your kids, you'll find that they are teaching you. You're not teaching them. So what we want to do today is give you an overview of the math contests, Math B contests. And I put together some slides. Some of this material will be overlapping with what Sai just presented, and we'll try to keep that minimum. And we'll be happy to take any questions after the session. Okay. So how to prepare for Math B contests. I also listed my email here. So what's a Math B contest? It's a math competition among Indian American kids. It's basically, the aim is that we want to nurture and enhance their math skills. We really want to see these kids do well, and they will do well once we make it fun, and once we make it that this is something they can develop passion for. And once you do that, then the sky is the limit. There's no telling how far they can go. And primarily we are looking at grades 1 through 8, and these contests are held as Sai mentioned, at regional level and then subsequently at national level. Based on the results of the regional level, these kids will be then selected for national levels. And what are the goals of the contest? Primarily, the goal is we want to make this math learning as fun. Okay, and once the learning is fun, then you really are not even thinking about it, and you're learning and you're enjoying it. And some of the things that I will present, hopefully in the second half, will emphasize how we can make problem solving in math learning a little bit more interesting and challenging and fun. So another goal is obviously we want to introduce some new math concepts. They may not have seen them in their class because obviously these are a little bit more advanced level, a little bit more challenging level, and this is a contest. This is not a regular exam that they take in their school. This is a contest, and because of that, the questions will be a little bit more challenging, a little bit more interesting, not using the conventional, plug in the numbers and get the answers. That's not the goal. The goal is to make you think and make you think critically. We also want to generate enthusiasm and love for math. That's obvious. We want to show you some problem solving skills, how to solve these problems, not in a routine manner that everybody does, but a little bit more interesting manner. Obviously, that's related to developing intuition. And then as a byproduct, these kids will then go on and do very well in their college entrance exam. So how do you sign up? Obviously, you're all familiar with this website, www.northsouth.org. So highly recommend if you haven't done it. I'm sure you have, but if you have not, please go there and just do the web surfing and find out a lot of information there about different things, including the curriculum, what are the contest rules, when are the contests going to be held, and much more. The contests for math are at 3 levels, 1, 2, and 3. And the grades are for Math B1, 1 and 2 grade, and for Math B2, 3, 4, and 5, Math B3, 6, 7, and 8. So kids in these grades can participate in their respective Math B contests. Phase 1 and Phase 2 is how we divide these contests in. The Phase 1 is a 25 questions, 35 minutes type contest. And Phase 2 is 20 questions given in 15 minutes. And I believe there will be a short break between the two phases. In the past, we have made Phase 1 to be open-ended kind of questions or free answer questions. But this time, because of all contests are online, both phases are multiple choice. So your kids will be given the question and then 4 choices, and then they have to pick one of the choices from that. Based on the performance of your students, they will be then invited to participate in the national exam, and that would be to be determined, I believe. So the contest schedule, as I mentioned, there are two weekends, April 10, 11, and May 1 and 2. And how do you prepare, right? I'm sure this is something that's on your mind. And I'm sure you have some ideas, and hopefully together we can customize this for your child. But there are some inherent basic fundamentals that we all should follow if we want to do well, not just in math, but any field. And that is, you must have fun with it. You can't do well if you're not having fun. If you're not having the joy is missing, you cannot do well. So make sure you have some kind of fun with it, and you devise methods of having fun. You can include math in your daily activities, right? Instead of posing questions, or talking about things in general, include math in your day-to-day discussion with your child, and don't present them boring, plug in the numbers type. Ask them to think critically, and then believe me, once you light that fire, they're gonna be teaching you. And then spend more than an hour. That's just a rough number, obviously. Encourage your child and provide help as needed. So you must be an active participant, active team player in this. You must interact with them, not just say, here's the book and do the problems. Must be involved in it. And obviously it's a good investment. It's a lifelong investment. And it's better than a conventional investment where money will not stay with you, but learning and knowledge do, as we all know. And then I have listed here Dr. Revoluti, who was my mentor, who is the father of Math V for NorthSouth Foundation. And he used to say this, and it has stuck with me. When you share money, you divide it. But when you share knowledge, you multiply it. And I'm sure you can attest to that. When you share your knowledge, the knowledge just comes back multiple folds to you. So Math B Level 1 is for grade 1 and 2. Developing critical thinking skills is very important at early stage. You're teaching your child how to think. There are some websites like Khan Academy, probably aware of it. If you're not, please go look up that on Google, and you will find a wealth of material there. There are online lessons, there are practice videos and problems that you can solve. Math Kangaroo is another nice website. I found it because their problems are a little bit more advanced and challenging, and kind of unconventional type thinking, and that's what you want. You want to develop that thinking outside the box kind of thing. Singapore math books are also another very useful resource, and you can check them out. In addition to these books on Singapore math, they also have a placement test where you can have your child take the test and kind of gauge where they are relative to the grade level. Math B Level 2 is for 3rd, 4th, and 5th grade. And again, Khan Academy, Math League contest books, and there's the website. And these are multiple choice type questions that they can attempt. There is another nice book, which is Math Olympiads for elementary and middle school. I have used that in my coaching as well as with my kids, and it's a very useful book. Singapore math book, again, grade appropriate books that you can search and take advantage of those. So there's a wealth of resources. This is just a snapshot of what we have found very helpful. Obviously, there are other resources that you can Google search and customize. One thing I would say is, based on my personal experience, do not overload. Do not bring in like hundreds of these resources and just pick and choose and see how your kid is responding, and then add or subtract as needed. Do not put a heavy amount of work in front of them. Now for 6th, 7th, and 8th grade, the choice is very simple, which is mathcounts.org. You cannot go wrong once you log on to that website and download the competition. They publish a book of past contests as well as problem solving, and highly recommend that. And that alone will get you probably 80-90% of what's needed for MB3. And then if you want to go further, you can log into this website, artofproblemsolving.com. I found it to be very helpful. And then obviously the other that we mentioned a few minutes ago. So those are great resources for parents and kids. Now, we want to switch gears and talk a little bit about type of problems, sample problems that your kid will be encountering in these contests. And so I will go through some of these, try to solve some of these problems with you. Hopefully your child is with you so they can also appreciate how the problem solving tricks and tips can be used. The goal here is not just to solve a problem, but to dig into the problem and appreciate what they are asking and how we can solve it in multiple different ways, and find the way that is uniquely interesting to you. And once you develop that skill, you will never forget it. So the goal is not just to solve by plugging in numbers, but find an interesting way that you will love and potentially show others how to do. So dress costs $120. How much will it cost after 30% discount? So we all know how to do these kind of problems, right? We say 120 And then we say 30% of that, which is 0.3, or 30 over 100. And that gives you, what does that give you? 36. And you say, okay, the discount is 36. That is the discount. And then I'm going to subtract that 120 from 36 from 120. And then I will get the answer, right? Which is 84. And there's nothing wrong with that. But you can make a shortcut. The shortcut is, if I want to know what does the dress cost after 30% discount, what I'm really saying is the net cost of the dress is 70% of 120. So rather than go through this unnecessary step of finding the discount, I just go for the final cost. So which would be 120 times 0.7. Okay? And that is 84. So what you've done, you probably saved 15 to 20 seconds or 30 seconds, which can be crucial in a contest. Remember, this is a time contest, time-based test. You don't want to waste any time. So if you introduce or think about these types of shortcuts, that will excite or generate more interest in your child. Then the next one is very easy. We'll skip through that. We'll go to the next one. Sum of two numbers is 240. If one number is twice the other, find the numbers. Now, again, you can think of some algebra way of doing it, but probably not very necessary. You're saying there are two numbers. Let's call them number A and number B. And what are we saying? One number is twice the other. So we can think of this number A to be not A, but two B's. There are two B's. So now what we have? We have three B's. Two B's for the first number, and third number is B. So we have three B's. So what we have done, I've listed just for convenience B's. You don't really need that. There are three units that add up to 240. And I want to know what are the numbers. So if three units add up to 240, one of the units must be 80. If one of the units is 80, the other number must be 160. So those are the numbers, right? So what you're doing is, of course, I've spent a lot of time thinking, writing it down. With your child, if you show them these kind of tricks, they will surprise you. What is the next number in the following sequence? So here, it's pattern recognition. What we're trying to do is we're trying to find, based on what the numbers are, recognize what the pattern is. And so here, 1, 2, 4, 7, 11, right? Depending on the grade level of your child, they will immediately recognize that there is some difference in these numbers. There's difference in these numbers is 1, difference in these numbers is 2, difference in these numbers is 3, and so forth, right? So the next number must be 50, because the difference previously was 4. The next difference is 5, so it must be 16. Right? So you say, okay, that's good enough. But I say, do not stop here. What you want to do is continue. See how far you can continue. And if your child says, oh, it's boring, you say, okay, how about we time you? How many can you write in 10 seconds? So you develop that kind of interesting twist to these problems and extensions to these problems, and see where they go. The next one is 2, 3, 5, 7, 11, and I'm sure your child will look at that and say, those are prime numbers, right? So then the next one is 13. Okay. Again, you don't want to say stop right there. Go on, because if your child can write all the prime numbers from 1 to 100, that is a significant achievement, because they will recognize these numbers quickly. And prime numbers are the building blocks, the fundamental building blocks, or if you want to say a carpenter's tool, that you have that in your back pocket whenever you need it in problem solving. The next one, of course, the next one here, 14 is not, 15 is not, 16 is not, but 17, right? And so forth. And it becomes a fun exercise. But those who do not know what prime numbers are, these are numbers that are very special in math that can only be divided by 1 and itself. So none of these numbers can be divided by any other number except 1 or the number itself. The next one, I'm sure your child can quickly recognize. These are square numbers, right? So 1 is a square of 1, 2, 4 is a square of 2, 3 square, 4 square, and then the next one is 5 square, and that would be 25. And again, you guessed it, I'm gonna say do not stop, just keep going, right? See how far you can go. At least till 10 square, which is 100, right? Obviously you can go further. And the next one is a very interesting series, very interesting concept. Someone came up with this. His name is Fibonacci, probably an Italian mathematician. And what we are seeing here, after the starting from the third number, every number is the sum of the previous two numbers. So 2 is a sum of 1 and 1, 3 is a sum of 2 and 1, 5 is a sum of 2 and 3, and so forth. So with that trick, this must be 21, right? And so forth. So you can see these are ordinary looking problems, but they have a lot of interesting concepts in it. So we're gonna move on to, let's see if I can, okay. See if I can clear this. Okay. So the next I presented, I won't be able to go through each of these for the sake of time, because I want to leave some time for questions. But I want to just show you some simple problems that your child will encounter. And some of these you're familiar with. These are like order of operations. How do you do simple addition, subtraction, multiplication, and division? And if you ask your child, if your math skills are rusty, you can ask them. They'll tell you that these have to be done in a specific order. The parentheses, exponent, multiplication, division, addition, subtraction, and that rule is called PEMDAS, which is a short form for another way to remember, please excuse my dear Aunt Sally. They'll tell you if you don't know. And then using the same tricks, you can do the other problems. This one's my favorite, the distributive law. See how complicated this one looks, 1767 times 7. So if you do not allow calculators, how would you do that quickly? Well, you recognize that 17 is common in both of these numbers. So you just take 17, which is a common number, as outside, and then multiply by the sum of 67 and 33. And 67 and 33 just add up to 100. So we get 1700. See how quickly you can break this thing down. It's kind of like being a detective. You try to find, you're trying to solve a problem by being a detective. And using the same rule, which is called the distributive law, it comes in very handy in math. We can solve the next one. And the one that I've just expanded on is another interesting rule. When a number is followed by an exclamation sign, that is a cute way or a smart way, however you want to call it, to write a very big number like 5 times 4 times 3 times 2 times 1 is just written simply as 5 factorial. Okay. And 3 factorial obviously is start from 3 and go down to 1 and put some multiplication signs in the middle. And when somebody asks you, hey, what is 5 factorial over 3 factorial? You really don't need to write all of this down, because you know in your mind that these all just go down from 5 to 1 and 3 to 1. So if this goes 3 to 1, this goes 5 to 1, and I'm just dividing, there must be some common numbers like 3 to 1. So all I'm left with is 5 times 4. So your child, once he grabs onto that concept, he said, I don't really need your help, Dad or Mom. I can do it myself, any number. And I just shown you a simple one. You can make it like 100 factorial over 98 factorial, right? And the answer is very quickly. You don't need a calculator. You can actually beat the calculator by saying 100 factorial over 98 factorial. Let me just write it down just so you know what I'm talking about. See how ugly that looks? 100 factorial over 98 factorial, right? Because we know these are just using the rule, 100 down to 1, 98 down to 1. So if we cancel out the numerator and denominator. What are we left with? 100 times 99. And you don't need a calculator. That is 9,900. Right? So once you show these things to your child, I've said this many times, and I can't overemphasize, they're not going to need your help. And the next one on this, let's close this out. Sorry. Pointer, which is, this is again looks pretty ugly, but if you combine them, 2 times 5, all raised to the power 4, you get the right answer. Right? So the next one is phase 2. Obviously, the phase 1 that we just showed you also will be multiple choice. And this is just an example of what a multiple choice problem will look like for MB1. So there are 3 friends who have a meeting scheduled at 12:30. And one of the friends takes 10 minutes, the other friend takes half an hour, quarter of an hour, and the last friend takes 40 minutes. So what time must the person who needs the longest time to get to the meeting leave her house? So in this case, the person who needs the longest time is 40 minutes, right, Anna? So that's what we need to, there are many concepts buried into this. So it's a first MB1 level problem. So the child must be able to recognize that this is the longest time. And if this is the longest time, you work backwards from 12:30 backwards on 40 minutes. And what do you get? Well, 12:30, I need to subtract 40. So what I do, I subtract 30 from this because that'll take me to 12, and then subtract another 10, and that takes me to 1150. So that's the answer. Now, this is level 2 problems now. So a little bit more interesting, a little bit more challenging. Because these are for grade levels 3, 4, and 5. So what we want to show here are concepts that require more advanced skills compared to the MB1 level. So I'm going to skip the first one. It's a very easy problem. I'm just going to go to the second one just to show you the concepts that are involved in solving these problems. So here we have a pattern. And the pattern looks very interesting, right? It's a very nice, you can think of it as a border on a painting, whatever the case may be. We have multiple different shapes, some shaded, some not shaded, these hearts, and they are oriented in a different order, different orientation in this picture. So first thing you should do is recognize the order. What is the order here? So I'm just going to try to make it simple. Again, this is not the only way to do it, but there are other ways to do it. And the order is, I want to make them be recognizable by a certain distinct feature. And look at the feature of the first, it's a heart. So I can say the pointy part of the heart is pointing down. And the pointy part of the heart is pointing to the left and to the top, to the right. So instead of focusing on these pictures, what if I just wrote this down as bottom, left, top, and right? Okay, and then again, the pattern is going to repeat itself. So bottom, left, top, right. So if I know which way the pointy end is, again, this is just one way. I'm sure your child will come up with even better way than I have shown you. But this is a way to show that these are groups of 4. Right? So if we continue this pattern will continue to infinity. So the question is, what is the next shape in this pattern? Well, the next shape in this pattern must be a shape which is B, right? And B, we know, is always unshaded. So that's a pattern, or that's the picture. And then if somebody says, what is the next shape? That would be shape number 10. And we know that would be one with the left, right? Now, that's easy. But if somebody asked you this seemingly difficult question, what is the 50th shape? My question is, would you want to draw this out? Maybe if you're not doing a contest, maybe even then not. but definitely not in a contest. You don't have time. Probably you have 15 seconds or 30 seconds to solve this problem, or maybe a minute at most. You don't have time to do this. So what do? Well, recognize, as we just pointed out, that these are groups of 4. So what if we did 50, which is the number that we are interested in, divide that by 4, what do we get? We get 12 remainder 2, right? So we don't really care about 12 because that's a group that's already taken care of, but we want to focus on the remainder 2. The remainder 2 tells me that this would be the second shape in the last group that is not completely full. That's why it's a remainder 2. So remainder 2, what is that? That's a left pointy heart and shaded. Now, you say, well, that's great. Now, what if this was because we are in year 2021 and somebody asked you, what would be the 221st shape? Now, if somebody told you this and you didn't know all this fancy stuff that we went through, you'll probably give up, right? But now that you know, you can solve that problem, and you can solve any problem. And you can then have your child impress their friends. Hey, look, I found a trick. So let's move on. Move on to the next one. Okay, so this is a algebra logic type problem. It's relatively simple, straightforward. I'm sure your child has seen something like this, where they give you a pattern, they give you facts. So this is fact number 1, and this is fact number 2. And they want to know if you know how the triangles are related to heart, and if you know how the stars are related to heart, and then you want to know how the triangles are related to stars, right? It's like given. So again, I'll leave this as a challenge for your child, and I'm sure they will be able to figure it out before you can do. So let them figure this out, and they will. And not only that, once they figure this out, hey, ask them, can you create another challenge for me? And that's when the fun begins. So now what I want to focus on is a geometry concept where they're asking you to find the area of the shaded region. Okay, so this is a rectangle. The length of the rectangle is 12, and the width of the rectangle is 6. And they're saying AD is equal to DE. So if AD is equal to DE, what do we know about this? We know that this is, oops, yeah, I went too fast. That's okay. This is 6, and this is 6. So there's a special name for these triangles. Okay, there's a special name for these triangles that have 2 sides equal. And if you ask your child, they'll whisper in your ears that this is a isosceles triangle. Okay, the 2 sides are equal. So what do we want to know in this? We want to know not the area of the triangle, but the area of the shaded region. And the shaded region does not look like anything that we have encountered in geometry very frequently. This is a trapezoid, but we don't come across it very easily, or very commonly. So what do we have here? We have a rectangle, and if we subtract the triangle from it, we get the shaded region. Very, very simple. And let's do that. The area of the rectangle is 72, 12 times 6, everybody knows. And area of the triangle is 1/2 base, which is 6, times the height, which is 6, and that gives you 18. So 72 minus 18 is 54. And that's the easy answer. Now, you don't stop there. You say, you ask your child to look up the area of a trapezoid. And now you know what this side is. If this side is 12, this side also must be 6. So you have 2 sides, 6 and 12, that are parallel, and one side, which is the separation, is 6. So now your child will surprise you and say, I found out this area of a trapezoid, which can work out to be the same number as this. All right, I'd leave that as a challenge for you rather than show you how to do it. You'll find that very, very interesting. So let's move on. Why? Okay, let's take a pause. Why am I talking about different ways? Because once you know different ways, then you can connect the dots. And once you connect the dots, then things really open up, and these layers that are hiding simple facts of math or simple tricks and tips will become very apparent. And then the fun and excitement begins. So I highly encourage, don't stop with this. Please look up the area of a trapezoid and confirm that there's another way to do it. Okay, so we move on. We're going to erase the drawing and we're going to go to pointer. Okay, all right, so this is of all the problems, and I've done a lot of problems with kids, but this is my all-time favorite, and I'll tell you why in a second. So here's a problem. There's Bill. There are two. There's a father who has a child. His name is Bill. So Dad and Bill, right? And the sum of their ages is 50 years. And we also are told that Bill is 30 years younger than his dad. So we know sum is 50 and the difference of their ages is 30. Now, if you did not know the trick that I'm going to show you, you're going to probably do it this way. Okay. And there are probably 10 to 12 steps. And each step is going to cost you about 10 seconds, okay, in the exam. And that may be just too long. So nothing wrong with this. This is perfectly fine if you have all the time in the world to do this. But oftentimes in exam, you don't have that luxury. So what I'm going to show you is a very simple trick which works with not just this problem, but any problem related to what this question is asking. And here's how it goes. So we're given two. We're given Dad, and we're given Bill. Just pretend that we can write them D and B. So what is the sum of their ages? Sum of their ages is 50. Difference of their ages is 30. Okay. Now, once you know that, and they want to know what is the age of either Dad or Bill, right? Let's say we want to know how old is Dad, the bigger number, right? What do you need to do? If somebody tells you the sum is 50 and the difference is 30, what do you need to do? Just add them up and divide by 2. And that's 40. And that's exactly this answer. So I probably spent 10 seconds or so writing all this down. But if I had not written it down and I knew the trick, I can do it in less than a second, right? In my mind. And that's where these kind of contests, they are really probing whether you know the shortcuts. They're really checking your ability to think quickly and solve these problems. And if somebody said, no, I don't want to know the dad's age, I want to know the Bill's age. So what do you do in that case, right? You do not do addition. You do not add 50 and 30. You subtract 30 from 50. And what do you get? 50 and 30. And you subtract again. You can do it faster if you don't write it down, which is 20 divided by 2, which is 10. So Bill is 10, right? Again, it depends on what they're asking. If they're asking the larger of the two numbers, you add them, divide by 2. Smaller the numbers, you subtract and divide by 2. Now, rather than stop here, what I ask you to do is think of extensions of this problem and present it to your child, right? Think of some other concepts related to this. And once they've grasped it, ask them to create these kind of problems for you. So we will stop with this and move on and to go to the next one. Oops, sorry about that. Okay, so this is another problem where you do not need paper or pencil. You just need to think through this visually. So what they're giving you is the larger square, which is the outer square, is an area of 100. and the vertices of the other square lie at the midpoints. So the smaller square picture is also a square, but they lie at the midpoints of the four sides. And we want to know the area of the smaller square, right? What is the area of the smaller square? Now, it's not very obvious, but if I were to tell you that the smaller square is 50% of the larger square, I don't think you will argue with me. You say, that's about right, right? But how do we know that, right? How do we know for sure that this is 50%, right? Well, in this case, 50% happens to be a choice. So if you're pressed for time, you can circle it. But I'm going to show you how you can quickly verify that or validate it. Because one of the important steps in solving problems in math is not just solve the problem, but make sure that you have not made a mistake. You validate it, you go back and check it. And of course, time permitting, you should always do that. It doesn't matter what kind of test or contest it is. Do not turn in your test and, oh, just because I have done it, there's nothing better to go back and review your questions and make edits as needed. So what I'm going to show you is how we can quickly validate this problem, this answer, which is C. So this is 10 because the area is 100. Each side is 10. So if each side is 10, and these are midpoints, this must be 5, and this must be 5. Correct? So if that's the case, let's play a little mind game. Let's play a mind game. The mind game is, let me pretend that this is a piece of paper, and I'm going to turn this triangle, fold it down. So if I fold this triangle down, what is it going to look like? It's going to look like this. So what I've done is I've flipped this triangle back this way. Now I can convince myself that when I flip it, this pointer must be at the center of the square. Why? Because this side is 5, and this side is 5, and this side is 5. So I'm really equally breaking up this big square into smaller squares, right, of 5 each. So I can obviously do the same thing with this one, with this one, and with this one. And when I do that, what do I get? I get a nice shape that looks like this. So now it's obvious that the choice 50 is correct. But now if you try to do it any other way, obviously there are other methods of geometry that you can use by putting square roots and Pythagoras theorem and all fun stuff, and nothing wrong with it. That's probably educational in their own way, but having a visual understanding, this is called, there's a word for it, proof without words or proof without equations. So they are proving this without any equations or any, so this is just proof with pictures. There's really a lot of fun in it, right? So I'm gonna erase all this. Hopefully that was interesting and no questions, and move on. So this is another problem where they're asking, what is the shortest side? This is now moving to a MB3 level. So the concepts are getting more challenging. And what we have here is we are given a big triangle, ABC, and we are asked to find this distance from O to B. Now, before we move on, let's pause because there are a lot of interesting concepts in this. One of the interesting concepts is that this is a Pythagoras triangle, Pythagorean triangle or Pythagoras triangle. Pythagoras triangle is a triangle where it's a right triangle shown by this square. Whenever you see a square or a rectangle on the corner of a vertex, that's an indication it's a right triangle or a 90-degree angle. So this is a 90-degree. Let me take my pen. It's a 90-degree angle. The other thing that's obvious from this is because it's a Pythagoras triangle, that this side square and this side square equals this side square. So what does that mean? If this is 3 and this is 4, this must be 5. because the square of 5 is square of 4 plus square of 3. Okay, so next thing they want to know is they don't want to know this side. That would be nice if they wanted to know this side, because the answer would be 5 before you could ask the question. They will tell you the answer because that's a 3, 4, 5 triangle. But that's not what they're asking. They're asking this distance. And there's a special name for this distance. It is called the altitude. Altitude is a fancy name for height of this triangle looking from this side as the base. Okay, so BO is the altitude. So now, how are we going to find it? And look, we're going to exploit the symmetry of this problem. We're going to exploit different concept which is buried into this, kind of like a detective. So if you are asked this distance, what do? Let's find out the area of this triangle. The area of this triangle ABC is simply the 1/2, shown here, 1/2 times the base times the height. This is the base and this is the height when I'm looking at this from the way it's drawn. This is the base of the triangle, this is the height of the triangle. And that turns out to be 6. Now, let's do something smart, which is, let's call this the base, right? So if we do that, look what happens. I'm going to switch to the pointer. So the area of the triangle can also be written as 1/2 AC times BO, because that's another way to do it. Just rotate the triangle. When you do that, you get 1/2 5, because that's the distance, that's the length of this, times BO. Now we know that this must equal 1/2 5 BO must equal 6, because there are different ways of writing the area, right? Doesn't matter how I calculate the area from here or here, I should still get the same answer. And if I exploit that simple concept, right, what did I do? I just rotated the triangle, made this 5 as the base instead of 4 as the base, and used a very simple rule of area of the triangle. I get the answer. Done, right? So hope that was clear. And once you show this to your child and they get the feel of it, they get the hang of it, they get the enthusiasm of how to do this. As I said again, I'll say it one more time, sky is the limit. So I'm going to go on. Okay, then this is a probability type question, right? So you're given 2 cubes. They're 6-sided cubes. There are 6 sides to the cube, and they're labeled 1 through 6. And we want to know, when you roll these 2 standard cubes, what is the probability that the sum of the top numbers, right? Because you always look at the top and say, what is the number? Sum of the numbers is 6, right? So you can get some of the numbers to be 6 in multiple different ways, and I'm going to go through that. There are 6 possible results for each roll of the cube, right? Each roll of the cube is independent of the other cube, right? So when I roll these 2 cubes, one cube does not determine how the other cube's going to react, right? So each rolls on its own, and there are 6 possible combinations for each roll, each cube. So since there are 6 possible rolls for each cube, and there are 6 possible combinations, 6 times 6 total possibilities of different combinations. So you can have total of 36 different results that will show up when you look at the top face of the cube. So that's obvious, right? That's understandable. Now we want to know, out of those 36, how many add up to be 6? So what do? You simply write them down. What are they, right? We're only interested in the sum of 6. What are the combinations? Well, here are the combinations. You can have 1 and 5. First cube is 1, second cube shows 5, or the first cube shows 5 and the second cube shows 1, right? There are 2 different cubes, so they can have 2 different ways of getting to 6. And you can get 2 and 4, or 4 and 2, or you can get 3 and 3. Right? Keep in mind that 3 and 3, there are no 2 choices. That's the only way you can get 3 and 3. So what do you find from this? You have 5 different choices. You can get first cube. You can color them. If you're not convinced that there are 2 different ways, you can color. You can color this cube red. You can color this cube green. And you'll see what I mean. You can get 1 and 5, 5 and 1, 2 and 4, 4 and 2, 3 and 3. And when you add them all up, there are 5 choices out of 36 total. So what is the answer? Right? The answer is 5 over 36. Right? There are 5 choices that are good and 36 choices that are total. So the answer is, so again, you probably can tell what I'm going to say now. Do not stop here. Create a different problem from this concept. How can you get sum of 5 or sum of some other numbers, right? So, or how can you get only prime numbers, right, on the cubes? So if you make this problem interesting, what I call it an extension of what I've just done, give them an extension. And that's where they're going to say, not only they're going to understand the concept, but they're going to go further with that. And that's what you want to do. You don't want to stop. You want to make this more interesting. And then once they get a hang of it, find other problems related like this in, in either in the contest books, and they say, hey, do you remember we did this problem like that? Can we apply that concept? And then say, oh, wow. Now, one other thing I want to share with you as it comes to my mind, and this is very important, and it kind of goes back to that heart problem that we talked about. Remember that heart problem with the heart shapes I talked about? Whenever you're faced with a problem that seems very challenging, very difficult, like if I had asked you what is the 221st shape, like I was telling you, what do? You always look for the easiest extension of that. Rather than solve the 221st, you solve for, hey, what would be the 10th shape? What would be the 15th shape? You look for the easiest extension, because easy ones you can grab on. And then you develop what we call a pattern. You recognize a pattern. Once you recognize the pattern, then you extend. So whenever a problem looks very difficult, you do not give up. You find a simple extension of it. Okay, just a trick that hopefully will come in handy sometime. So I'm going to move on to this one, and this is another problem that is very interesting, and I like it a lot. And hopefully I can convey some of the excitement that is related to this problem solving. On the surface, it looks pretty dry and almost looks intimidating and boring, but it is actually a lot of fun. So let's go through this. How many ounces of a solution that is 30% salt must be added to a 50-ounce solution that is 10% salt so that the resulting solution is 20% salt? So by just reading that problem, it's probably driving you to sleep. And I don't blame you. So what do? You do not try to solve it as it's written. What you do is you create a picture. So let's see if we can create a picture. So we're going to create 2 containers. Here's another container. And what are they saying? There's a 30% salt solution and there's a 10% salt solution. So let's call this one 30%. And let's call it 10%. Okay? So we have two flasks or 2 containers with some things in them. They're 30% and 10%. Next, what do we want to do? We want to add them up. And we are also given that the 10% is 50 ounce. So we'll just put 50 ounce there. It doesn't matter. It could be 50 liters, but let's just say 50 ounce. So if it's 50 ounce, we want to know how much should we add of 30 to this so that we get a 20% solution, right? That's the question, right? Now that I've shown you this, hopefully the problem is less intimidating, right? So we want to know how much should I add of this? How many ounces should I add of this in this so I get this? Easy, right? Now, it doesn't take rocket scientists to know if I have a 30% solution and a 10% solution, and I want 20, I want something in the middle, right? What do I need to do? I need to have equal of each. I need to have 50 ounce of this and 50 ounce of this to get 20% of this, right? That's does not require any, you can probably get that logical without even knowing any math, right? So another way of thinking is if you have scored 80% in one test and 100% in the other test, there are only two tests, right? So what are you going to get this combination? 90%, right? Somewhere in the middle. So whenever they want to know the answer to be the 20% solution, when one is 30, the other is 10, just add them in equal quantities. It's no rocket science. But now, and that's the answer, right? It did not require any math. Of course, you can do it with algebra. But I want to throw a challenge to you. What if they were not asking for 20% solution? They were asking for 25% solution. What would you do then? How many ounces of 30% should you have if the one was 10% and the other was 30%? How would you do? Well, what you can do is think of this problem as a seesaw problem. Of course, you can think of other ways. Let's create a seesaw. And one of them is a 10%. The other one is a 30%. And we can pretend that this is a child and this is a dad, right? 10% is a child, this is a dad. If they were both, if we wanted something in the middle, right? We put them right in the middle, right? But if we wanted one of them to be 25%, then we need, right now this is 20%, right? So we need equal quantities of each. But if we said we don't want 20%, but we want somewhere in the middle right here, then we know right away that we want to balance it here. So one side is only 5 away from 30, the other one is 15 away from 30. Right? So you see that, what I did? One side is only 5 away, 25, right? One is 5 away from 30, the other one is 15 away from 10. So you have the ratio, you can call it 1 to 3. There's a 3 to 1 ratio. So when that's the case, if you want to have, and your number 25 is closer to 30, so the ratio of what you're going to have with 10% and what you're going to have with 30% should be in the 3 to 1 ratio. And obviously 30% should be greater amount because you're closer to that. So this one, if this is 50 ounces and the ratio is 3 to 1, this must be 150 ounces. Okay, so think about this and create other extensions of this problem. Right? I went through it a little quickly, more quickly than probably I should have, but in the interest of time, I just given you a kind of like a window into how you look at these problems without going through fancy algebra. Of course, you can do it that way too, and you'll get the answer. Let me erase this and go to the pointer, and that's how they did it, right? They came up with 50 ounces. The next one, I think I'm going to look at the clock. It looks like we are running out of time, so I'm going to skip over this one in the interest of time. This is not that difficult. And this one, I'm also going to skip just in the interest of time. I want to leave some time for questions. And this one, I will just spend less than a minute. Which of the following cannot be the lengths of 3 sides of a triangle? So there are 3 triplets, basically. These are the sides of the triangle given, 1, 2, 4, 3, 4, 6, etc. Here, the simple trick is that sum of any 2 sides must be larger than the third side. And lo and behold, from A, 1 and 2, when you add them up, that is not larger than 4. So whenever you have that problem, when sum of 1 and 2 is not larger than 4, that is the answer. That is the bad, that's the bad guy. That does not add up to be a triangle. All the others you'll see do add up to be. And again, your child will tell you if you don't know the rules. And I'll have to skip this interest of time and just show you some Practice books, Singapore Math books. Please go on the website singaporemath.com, and you'll get wealth of information there. Here are the Math League books. You can buy them, or you can get sample. There are a lot of sample questions, free available. Download them. And then here is the AOPS website, and tons of information and math counts. Please do go in there. And then NSF also offers coaching, online coaching, and that starts sometimes in August, goes on for about 15 weeks. I'm sorry, classes start in September, registration in August, and they are for all grade levels. And the good thing is you can sign up at a time slot of your convenience. And then there is online workshops, as Ambu mentioned earlier, and these are 2-hour long workshops. They will be offered in January, February, so you have not missed the boat on this. Please be looking out for the information on when we will be going through this. And finally, I'm going to stop here and let the Ambu and Sai and team take over. Thank you very much.
Thank you, Anil. That was great. I think many of these kids have benefited from the tips and tricks that you gave, made math exciting. So go to northsouth.org, go to US activities, and if you go to contests, regionals, online, that's where you'll find all the information. So if you click on math, it's got the general info, rules, the syllabus, the preparation, the frequently asked questions, everything is there. When you register, if you are a new user, so you would say new user parent, and you can go through the process of registering, which Sai touched upon. And when you are registered and you're ready, you just come into your account. When you log in, this is what my parent login looks like. And if you'll see that the contest regional is the first tab that is available. So when the registration opens, hopefully by Tuesday it will open, and your chapter director also will open it. You just click on register for region contest. Once you've registered, gone through that screens, you can click on the view status for regional contest and download, where Dr. Anil mentioned about SLP guide and all, download it, as well as you'll see the links where you will click on when you actually take the contest.
No, I want to thank you all. First of all, we could not do this without NSF, North South Foundation. We could not do this. And most importantly, we cannot do this without the parents and the children. So we want to thank you for being so interested in math. Thank you so much.
Um, we will be announcing the deep dive sessions shortly. These will once again come in your account. You'll see this online workshop where you can register for the online workshop based on your kids' um, eligibility. You will see the registrations that are available. Once again, in all of these, we have the registration as well as the view status, which would be the important links that you'll be clicking on. If you still have questions, like Sai said, email us and contest at northsouth.org. That concludes this information session. Thanks to all.